Good morning. Welcome to Cimarron's webinar on smokeless performance on flares. My name is Brian Lunger, and I'm going to be your facilitator today. Joining me on a panel is Mr. Goudier Pierre Beck and Mr. Robert Webb.
Right.
Both Goudier and Robert have a numerous amount of experience in production equipment and flaring and design. Today, we're going to have a quick agenda going over a few items. One of the items is going to be state of flaring, current and past in the media. We're also going to talk about compliance and non-compliance and why that's important. Also, what drives smokeless flaring, and also how to achieve smokeless performance from purge to peak. We'll also, assuming we have enough time at the end, answer a few questions. We would also like to share that in the live chat section, please post any questions or comments that you have, and we'll address those towards the end. Now, to begin with the webinar, let's talk about what got us here. Goudier, why is the industry hearing so much negative press about flaring?
Well, it's a good question, and that's why I think we have such a large audience today. We have had over 200 people who registered and still counting. There's no denying that the subject of flaring is, especially in the United States, has become a hot topic in the media in the past few years, with the headlines, for example, focusing on the pollution generated by flares on a daily basis. Just for the purpose of the webinar, I pulled some headlines for the last few days, and it's just all over the news. It's crazy. So what I think is there's a lot of emotions associated to this subject in the media, but very few actual facts trying to explain why flaring is necessary today and why we still have flares. And when you look all over the world, there is a similar focus on air quality, and particularly in Europe, where this is really an expectation from everyone. So it is in media, in my opinion, because it's a subject that is dear to the public's heart, and especially the newer generations. They were raised with that expectation that the earth needs protected. And I have two little kids at home, and they love the job I do in the oil and gas industry, but they expect, it's in their DNA today that we're protecting the earth. So it is, that's the way it is, you know. So to that effect, I'm going to share a video right now, and it's going to run in the background. But this is, it's an emotional subject. And because there's a large amount of flaring going on, especially in the oil-producing regions of the world, or in the US, it would be West Texas or New Mexico. And unfortunately, there's still a large emissions that are leaking through equipment, or flare that are not functioning properly, or they're poorly designed, and that's what we're going to talk about in a minute. So the media has locked in on the inefficiencies and with some of the flaring, and they generalized it to the whole industry.
Well, Goudier, it's very interesting. The video there, nice of a production facility, and seeing the smoking there. The perception and emotion that you're talking about. Robert, what are your thoughts on that?
You know, I think it's always bothered people that see smoke and flares. I think we just see more and more of them, and you sort of come to a breaking point. There were so many flares installed prior to the regulations being strengthened that it seemed like someone just didn't care back then.
So is it possible that we could eliminate flaring in the industry as a whole?
Maybe someday, but not right now. I would much rather gather the gas and push the vapors into a sales line or a gas takeaway line, and it pop out into somebody's water heater or furnace than it to just simply waste it. But the infrastructure just is not there. They're building larger and more gas takeaway lines, but they're just not there yet. They're moving forward, but not there yet.
Yeah, and for example, in the oil production side of the industry, I don't know what's going on with my screen. Sorry, guys, we're going live for the first time, and my screen is messed up. I'm just gonna go back here. In the oil and gas side of the industry, natural gas is a byproduct So it's an annoyance because it leaks and the air very easily. So there is no, if there's no gas pipeline available, what do you do with the gas? So the easiest way is to burn it. That's what is commonly known as routing flaring. But you also need to be ready for emergencies. If vapor recovery unit goes down or anything goes wrong, you need to have an emergency flares, and the emergency flares will never go away.
Yeah, that's right, G. And you know, the other markets, talking about petrochem, refining, and other sections of the industry that use flares, they have process flares and emergency flares as well that require the same, you know, they have performance requirements and design requirements. So let's move on a little bit. We've been talking at kind of a high level regarding media and flaring in the news. Let's kind of get down to the ground level. Regarding flaring, I mean, what keeps the owners, operators up at night in the industry?
I bet most operators have had a dream or two about waking up to an email from the EPA that a drone has flown over one of their facilities and they want to talk to them. So you know, kind of like the video that we just saw. I guess being caught out of compliance, or even worse, you know, by the media.
Yes, and I agree with Robert. I've had in the past couple of years several operators call me because they ended up in the 6 o'clock news, local news, with smoking flares being reported to the media by an angry neighbor. I live in Oklahoma, which is usually was very supportive of the oil and gas industry, and we see the more and more the general public using their cell phone camera, and they will post that on social media, and it will damage the company image immediately if it starts spreading. And I'll give you an example. How many times have we seen and laughed maybe about those videos of a flight attendant dealing a bit roughly with passengers, and it is filmed from the perspective of the passenger, so it will look bad, even though the flight attendant might be right. So, and just again for the webinar purpose, I just did some research on YouTube, and I found so many people posting and really showing flares that are smoking near their area where they live, and reporting them. So it's terrible.
Yeah. So G, how do the operators react to this new threat? What do they do?
So it's a very good question. So most companies are now adopting, and that's something that maybe the audience doesn't know, what is commonly known as ESG. An ESG policy stands for environmental, social, and corporate guidance. And this is something that is very important in Wall Street or for investors. It is kind of a way of, just like we have quality control policy, we have safety policy in a company. Now you need to have almost like a social media policy. How can you be and give the image that you're a good neighbor, you do the right thing for the community and the environment? But I'll tell you what, it goes far, because the investors, people don't like to invest anymore in the oil and gas industry, especially if there is that image that we're polluting. So you're seeing more and more large corporations and oil and gas industries that are not waiting to be compliant. They're going beyond compliance. They want to target zero emissions, so they have they're a good neighbor. The perception, the image they provide to the public is being good neighbors. And in fact, some operators, executives today, and we're seeing that tremendously the last few months and years, is executives at the top level are measured, and their bonuses are based on lowering the carbon emissions and on the ESG as well. So back at you, Brian.
Yeah, absolutely, G. This is why the subject of smokeless flaring is so important. So if we can't eliminate flaring, how do we eliminate smoking flares? So, I mean, Robert, is there any guidelines that define smokeless flaring, or what is smoke?
Yes, it's known as the Ringelmann scale. The EPA mandates that a flare tip shall be designed to Ringelmann 1 or less. So that's 20% opacity, as you see in the slide. But we at Cimarron, we go for Ringelmann 0 at max, clear blue sky.
So beyond the Ringelmann scale, is there other guidelines and regulations to follow regarding the smokeless flaring
There are several other regulations in the U.S. and in international as well, very complex regulations. In the U.S., there's the Title V that limits emissions on a rolling 12-month view for a facility, and there's 40 CFR 60.18. It's a minimum design standard that flaring equipment must be operated to. Personally, I think that anyone shouldn't set the bar as low as minimum. It hurts my soul to see a smoking flare, because it just doesn't have to be that way. So, I mean, I guess the moral of the story is to partner with an expert vendor.
Yeah, I agree, Robert. And I add to this, and it's important that there's no denying that in the combustion industry, you get what you pay for. If you want to be cheap on flares, meaning you're not using any technology to achieve smokeless conditions over a certain range, it will catch up to you very soon, because as soon as a flare smokes, the cost impact can be tremendous. We have customers who tell us all the time they get fined when they're caught, sometimes $15,000 a day until they resolve the problem. That can be tremendous. And but I think more than anything today, it's the cost of damage control for your company brand name.
Absolutely, the brand of a company and their image in the environment is very important. When you're talking about the design of regulations you're going to follow for your design of your systems and things like that, that kind of leads us into the next discussion about the flare design and how can a flare be smokeless?
Well, there have been smokeless flares since the 40s. Some gases or some vapors can be smokeless in something as unsophisticated as a raw-ended pipe flare. It all depends on the makeup of the gas and the air-fuel boundaries. Some vapors don't smoke at all, but most upstream facility vapors will smoke when the tip's not designed correctly or operated correctly. There's smoke. You have performance issues. Here's a picture. This is a flare in the Middle East, and both of these pictures are the exact same gas flow.
Yeah, and by the way, at Cimarron, we're focused on creating a cleaner environment, and we have invested in flare technology by acquiring recently Aerion, a very reputable flare company, and you guys, actually, you folks are former Aerion, and really appreciate having you in the team. We're doing, it's really exciting. But we are invested in flare in the technology, even though there's bad price out there, because it is absolutely possible to have smokeless performance with flares. And we do have experienced technical advisors, and we have solutions for any issues operators may face. So it's very important, maybe through this webinar for the audience, if sometime you face issues, you don't know who to reach out, don't hesitate, keep us in mind, because we have the resources to help you out. So
what else you can share, Robert, regarding composition, combustion, and smokeless flaring in general?
Well, basically, flame is a chemical reaction and requires the correct amount of air at the right time in the combustion process to oxidize the gas. You need the air to be readily available at the beginning of the process. Too much air, over aeration can occur, and you get incomplete combustion. But too much air, too little air in the process, and you don't have what it needs to oxidize each molecule of hydrogen and carbon into water vapor and CO2. Basically, little chains start to form of carbon, and now these chains are microscopic, but if enough of them get together, you can see them, and we call that smoke. And this is what it looks like when those chains get too close together. But if it's done right, the process of burning hydrocarbons, such as methane shown here, are water vapor, CO2, and nitrogen. It basically strips the nitrogen off of air and joins with the carbon or the hydrogen. And all of this is found in the air that we breathe every day. There's a lot of science that goes into tip design. You need the right stoichiometry to achieve 100% smokeless combustion, and that's where our 36 years of tip design come in handy.
So speaking of tip design and smokeless design on flares, what limitations and challenges are faced when selecting a smokeless flare design?
Well, I mean, there are many. If utilities on site, 480 three-phase power or assist gas availability, the facility layout, is it conducive to one flare or two? CapEx budgets, operating expenses, for future OpEx expensive, all drive the technology selection.
Yeah, so that seems like that's a lot there to have to work with to get the right design and technology out there. So I guess I'd ask, what are some of those technologies to achieve that smokeless flaring?
Well, there's several different tip technologies used. I say this all the time. If you have pressure, I can do magical things with it. But if you don't, I've got to reach into my bag of tricks and pull out air or steam or gas assist to make the gas burn smokelessly. One of the more cost-effective ways to do this is with pressure. You already have the pressure coming off your heater treater or your VRT. You might as well use that pressure to push the gas through a smaller exit area and create that motive force to mix the air with the gas, that's needed for combustion. But if you don't have the pressure, there are other mediums. For example, an air flare basically it's a blower that forces air through an outer air annulus around a gas riser for the air to mix with the gas or the vapor right at the tip, the top of the flare. I know it's not as simple as that, but it's really not that far from it. You see these pictures. You see the blower, the little green blower below the air annulus on the right hand side. There's that on our standard Cimarron air flare, and then you see the blue arrow that's pointing at what I was talking about earlier, the air fuel boundary. There's air around the outside of the gas mixture.
So when you're talking about, so Robert, when you're talking about the different technologies there, and you also talk about some of the variables that are challenges. For example, if you don't have 483 phase or power out there, what's another technology to use?
Well, this brings us to gas assist flare. Assist gas is injected into the envelope of the flame, and when that gas is pushed through the high pressure nozzles, and you can kind of see them in that picture, the little birthday candles around the flame, as the gas, whatever volume of gas you push into that envelope, it pulls a certain volume of air in with it. So it could be 7 to 21 times the volume of the gas that you're pushing into the flame, and that's what aerates the flame. What's that?
No, I was just going to say, so as we're talking about the different basics of smokeless flare technologies and what makes a flare smokeless, what's the next major hurdle?
In the U.S., I'd say it would most probably be the Title V emissions. Only allowing a certain number of tons of hazardous air pollutants per year. The economics of scale can only be extended to the amount of wells that you can squeeze in under that limit. With the infrastructure limitations and facilities getting larger and larger, I think that what we can do is keep charging up the hill and create more and more efficient flares to increase the destruction and removal efficiencies, the DRE. We've been testing our flares, and the majority of them have tested higher than the EPA's 98% DRE, and we've tested north of 99%. So going from 98% to 99. It doesn't seem like much, but it's huge. You just reduced your emissions from 50%, from 2% to 1%. This basically means that you can either extract more oil out of the same facility faster, or you can add more wells without having to build another facility. I mean, like I said, it's huge.
Yeah, Robert, I think you bring something very important here for the audience, is that if you can improve the value added of increasing the destruction and removal efficient, basically, rate, and cutting it in half, that means for a permitted well site like we have in the US, you can actually bring more production, and this is dollars. This is money. Either you save money or you make more because you can produce more. So I don't know if our audience have considered this. I know some of our customers have, but this is probably the biggest opportunity and the easiest to achieve. And of course, I don't know if we're going to have time to take questions later, but I welcome the audience to contact us to talk if you're interested in this subject.
So we're talking about, a flare that's designed for smokeless performance. Its emissions are going to be reduced. Destruction efficiencies are much higher. You're able to, reduce your costs, increase your production out of the wells. What are some of the other ways that utilizing that technology can their clients or the operators in the field save more on cost?
Yeah, if you're okay, Robert, I'll start on this one. There are a lot of opportunities for cost reductions when we're talking about flare design, using the latest technologies that we should address here. So first of all, you can combine, I mentioned routine flare and emergency flare. You can combine two combustion devices, like a low pressure coming from tanks and high pressure for emergency, into one unique device. That's an opportunity. I don't know if many people are taking that opportunity, but this is something that should be considered. Another one is utility on-site electricity. It costs money to generate electricity when you're in the middle of nowhere. So if you can reduce that by when using a blower significantly, that's an opportunity. Simplifying the maintenance by using retractable pilots. We don't see many of these out there, but this is such an opportunity. A big one coming up now is using automation to allow predictive maintenance, real-time monitoring, and use technology to increase, that's a good one, the range for smokeless performance from peak to purge. And that's one of our titles that you mentioned earlier. But this is important. A flare that is very forgiving, that has a wide range and is smokeless all the time, it's critical. These are just a few examples I had that came to my mind.
We actually have a patent pending new tip that was designed to address most of these issues. It's a dual tip flare that uses pressure assist for the high pressure vapors and then uses air or gas assist for the low pressure vapors in the same flare. It was designed to handle the increasing amounts of high pressure gas and tank vapors of today's larger facilities, while actually increasing the DRE and reducing utility consumptions. And it requires the assist gas medium for only the low pressure vapors. I mean, if you take a look at this CFD study, you notice the arrows coming out of the low pressure zone. G, can you point at that?
Yeah, it should be showing right now.
Well, can you point at it with your pointer? The low pressure gas comes out underneath the bowl. Well, that's the assist gas as it comes out. But basically, you can tell by the arrows, the direction of the arrows, that when the high pressure gas is coming out, it actually acts as an eductor and pulls the low pressure gas with it. So it's just along for the ride. It actually pulls it out and decreases friction losses. Now there's another slide, G. Now take a look at these two CFD profiles, and the one on the left is 15 million standard cubic feet a day, and the one on the right is 31 million. It's the same tip. The thing is, the more you give to it, the better it acts. The flare the flame actually stands up more erect the more that you give it. And anyway, it's pretty futuristic. We've also developed predictive algorithms that they either ramp up or slow down a blower for us to achieve the perfect stoichiometric mixture to achieve 99 DRE in our flares, and from purge to peak. But that may be a topic for another day.
Absolutely, Robert. Now, one of the things I wanted to point out is that we've gone through all the summaries of different types of technology and challenges and limitations and everything that goes in to develop the technology. It's not just throwing some metal together, welding it up, and putting it out there to perform. It's definitely an engineered product that's going to cover purge to peak on our slogan for the whole operations that operators need out there. Now, as our time is coming close, G, I'll pass it over to you for some closing remarks.
Yes, thank you, Brian. So, yeah, we did not have the pretension to cover everything about smokeless flares in a 30-minute webinar, but we wanted to go from 10,000 feet, talk about the big picture, how it impacts the behavior of companies today, to ideally give some hints from the ground level to facilities engineers that there are ways to save cost with smokeless flares. And in fact, I didn't even mention the modularization. What about modularizing flares? There's so many opportunities, and this is one of our I think our specialty at Cimarron, and we love those things. However, we'll try to limit this to 30 minutes, but we have a few questions, and I might actually, one is very interesting. A gentleman is saying that they have an air assist flare on site to prevent smoking. However, there are issues with controlling the blower motor speed with varying rates. Do you have a recommendation for what type of measurement to use in this application, or how to set up the control system? I don't know if, Robert, you can get into this.
Well, I mean, basically they typically have, say, a thermal mass flow meter, and you take the 4 to 20 signal into our predictive algorithm that we're talking about, and we can give set points as to where to either speed up or slow down that blower to achieve the correct mixture. As for set points, get with us offline. We can run our predictive algorithm.
I have another question, and that one is actually, it's not a bad one. It's clarification. Cimarron, Arion, when we buy a flare from Cimarron, what are we getting? So I think it's important to clarify that. So Cimarron has acquired in the last year several companies to complete the whole portfolio of solutions for environmental solutions. And Highborn EDI provides VRUs. Arion is bringing flare technologies. We actually have integrated all those companies together to create the new Cimarron. So we're recognizing and we acknowledge the strength of those brands. So when you buy or you contact Cimarron for a flare, you will get an Arion flare with all the support behind, the engineering team, field service, and everything. So I just wanted to clarify that it's just a new family, but we're keeping the brand together. I have another question. Is there an adequate method to predict smoke production based on the gas characteristics of flaring conditions?
Is there a what?
Is there a good method to predict smoke production based on the gas characteristics, the gas specifications?
That's what I was talking about, the predictive algorithm. You have to have the right stoichiometry. It's a C plus H over 4 calculation. It's a little deeper than that, but you get where I'm going. We need an accurate gas analysis, and I understand that it changes and varies throughout the year's production. But we would need to go in and calculate how much air for each volume of that particular gas. It's exactly what I was talking about, the predictive algorithm that we've generated over the years.
So I see that getting a lot of technical questions. My suggestion is to not get into those details here, but maybe we connect by email or by phone, and try to keep the time for our audience to the 30 minutes that we dedicated to this webinar. What do you think, Brian?
No, absolutely. I think that's great. We can the biggest thing we can do is we can review the questions from that came through the webinar, through the live chat, and we can publicize some answers to those and share those out there, whether we post it on the Cimarron.com website or we post another link to all the attendees. I think there's no problem doing that to get some feedback to each one of the audience members that have participated today and taken time out of their day to join our webinar.
Yeah.
So I'd also like to thank you and Robert and all the Cimarron team supporting the webinar and really getting this thing going. And we feel like this is going to be one of the beginning of the future where we're going on sharing information and regarding our technologies.
Thank you.
Thank you.
Thank you.